Okay, so I'm going to look at question 1 here, and we're just going to do it the method we've already learned, and then we're going to look for some patterns to see if maybe we can do it even faster. So 1a and b, those are simple trinomials because it's just x squared, which means 1x squared. So remember, you just set up your brackets with an x to start, and you're looking for two numbers that multiply to 25, add to negative 10. Well, choices 25 and 1 or 5 and 5. 5 and 5, obviously, but both have to be negative so that they add to negative 10 and multiply to positive 25. Notice that those are the same factors, so we can show this as x minus 5 all squared, right? If you have a repeated factor, you can show it as a power. Simple trinomial in the next one, x and x. Two numbers that multiply to 64 and add to 16, yeah, 8 and 8. Both positive because they add to a positive there. So you can leave it like that, or you could show it as x plus 8 squared. Okay, I'll give you a minute to work on the next two. Those are non-simple. I'm going to do C, decomposition, and I'm going to do D as inspection method, just to remind you. No matter which of those two, I still need to find two numbers that multiply to 9 in C and add to negative 6. So factors of 9 that add to negative 6, obviously 9 and 1 don't work, but 3 and 3, where they're both negative, works. So for decomposition, you copy out the first term, you decompose the second term, copy out the last, and factor those groups. Okay, so 3x is common. You're left with 3x minus 1. You copy out whatever the next sign is. It's a minus. And so I'm really factoring out a negative 1 there. So I'm left with 3x minus 1. The bracket has to be the same. If you have 3x plus 1, then you did something wrong, right? So then your common factor is 3x minus 1, and you're left with 3x minus 1, which is a repeated factor. That's the long way, but that's the mathematical way of doing it. Okay, the other way is inspection. So for the last one, two numbers that multiply to 100 and add to 20. 10 and 10, both positive. So now, I'm not going to use decomposition. I'm going to set up my brackets. I could have a choice of 4x and x. Okay, so what did we say? That was 10 and 10. 4x and x. But think about it. If I put 4x and x here, there's no way I can get 10 by when multiplying back. So it can't be 4x. It's got to be 2 and 2. So 2x at the beginning of both. Then to get 10 on the outside, that would have to be plus 5. And 10 on the inside, that would be plus 5. And again, repeated binomial. Okay. So just to read back up what it said above it, factoring perfect square trinomials. So what are perfect square trinomials? So they are basically what you get when you square a binomial. So a trinomial means you have 3 terms. So all of these have 3 terms. And if they can factor to a binomial squared, then they're called a perfect square trinomial. You have to know that terminology because we will ask you on a test, is this a perfect square trinomial? If you don't know what that is, pretty hard to say yes or no, right? if we can recognize it's a perfect square trinomial before we factor it, we can do it a little bit faster. So take a look at these numbers here. So this was a perfect square, okay, positive 25, the root was 5. That's the constant term. The product of, when we show it the long way, we're doing the outside and inside, add to the middle term. So that should be double the root of negative 25. Positive 25. So root of 25 is 5, doubled is 10. Whatever sign is in the question is whatever is the sign that's in the binomial. Okay? The last term has to be positive. I'm just going to erase my red so that you can see that. If it's not positive, then it's not a perfect square trinomial. So here, root of 64 is 8. 8 doubled is 16. So I know that that's a perfect square trinomial and factors to x plus whatever the root of 64 is. Those were nice because they were simple trinomials. What's the difference here? Well, 1 is a perfect square. Okay, so the root is 1, but we also have to check the first term. Because if the first term isn't a perfect square, then you can't do the method. Guys at the back, you paying attention? So root of 9x squared is 3x. Okay, so 3x. The root of 1 is 1. The product of those two doubled has to be the middle term. And it is, as long as we keep a negative with it. Here, the root of 4x squared is 2x. Root of 25 is 5. 2x times 5 is 10x. Doubled is 20x. So the root of each of those terms are the terms in the binomial. You do not have to do it by inspecting that, but it sure makes things faster. So this is the general case. If you've got your first term and you take the root of it is a, root of this is b. If the product of those two terms doubled is your middle term, then it factors just to a plus b, all squared. If it's a minus there, then it's a minus. So that's all the difference. But it has to be double the product. Okay, so another way to think about it is if it's, so there's a non-simple, there's a simple, okay? So basically, when you take half of the b and square it, you should get the product a times c. So either way you look at it, I did it the other way, but that's another way to look at it, okay? So if you look here, let's go back to one of these. If I take 20 and divide by 2 and square it, what do I get? Well, 20 divided by 2 is 10, squared is 100. What's 4 times 25? It's 100, so that's a perfect square trinomial. Okay. So A and C will always be a positive number, or positive numbers, and are both perfect squares. So if A or C were negative, if they're both negative, you could factor out a negative, and maybe it still is, but if one or the other, then it's not a perfect square trinomial. Okay, so in this next one, we're not factoring. We are just circling the trinomials that are considered perfect square trinomials. So the method from here is to go, okay, negative 12b divided by 2 squared. Do it in your head. Do it in your calculator. I don't care. But negative 12 divided by 2 is 6. Squared is 36. Is 1 times 25 36? Nope. Last time I checked, it wasn't. So that is not a perfect square trinomial. Negative 6 over 2 squared. Always going to be positive. So that's negative 3 squared is positive 9. I didn't even actually need to check this one. Take a look at the the sign in front of the constant term. It was negative. So that for sure is not. Didn't even need to do any work with numbers. Next one. So let's do negative 14 divided by 2 is, and then square it. That's negative 7 squared is positive 49. 1 times 49, yeah, it is. If it is, then let's write it in factored form. So we know it's a binomial squared. X to start, not minus, it's going to be a plus because of that sign in front of the 14. Whatever that is, it goes here. Root of 49 is 7. Okay. Those were all simple trinomials. Next one, okay, so we've got a positive first and last term. So let's take negative 12 divided by 2 and square it. We already did that in the first one. It's 36, right, in A. But now we have to check. Is 9 times 4 36? Yes. So it is. Oh, I guess we're supposed to circle it, right? So I'll circle that, circle this, and then factor it. So set up your bracket, all squared. You take the root of each term, each first term and last term. So root of 9x squared is 3x. Root of 4 is 2. The sign in front of the x term is negative. So it's going to be 3x minus 2. You can always check by expanding back. What about E? Looking at it. No. Negative 3. Subtracting, and it's not a perfect square. So that is not. Maybe you could common factor, but there wasn't anything. Always check, but there's no common factor in this one either. It is a positive, but is 2 a perfect square? No. No. So that can't be factored that way. Okay? Maybe you can factor it, but it's not a perfect square trinomial. So this, let's see, could we find two numbers that multiply to negative 12 and add to 11? What do you think? How about 12 and negative 1? So this can be factored, but not to a perfect square trinomial, right? So we can find those two numbers. Going to be 4x and x, because if we did 2 and 2, we could never get a 1 when we expand back. So then our outside could be plus 3 to give positive 12, and our inside would be negative 1. Okay, so that's a non-simple trinomial. It is not a perfect square trinomial. That's why I crossed it off. So you can factor it, but it's not a perfect square trinomial. This next one, two numbers that multiply to 12 and add to negative 13. Can you find two numbers for that? What about 12 and 1? Is 13, so negative 12 and negative 1. So when we factor this, again, it's not a perfect square trinomial, but we have to get these two numbers, so very similar to the last one, except they're both negative. And we have to get those from the outside and the inside. So 6x and x doesn't make sense. Actually, just a sec here, 12. So negative 12 and negative 1, yeah, that works. So what do I need to do here? I need to have 6x and x, actually. So that I can get negative 12 by making that subtract 2, and I can get minus 1 to get the negative 1 when I expand back. So not perfect square trinomials, but they are factorable. Okay, so you try the next one, 3, A, B, and C. See if you can do them the fast way. It's a repeated factor, the same factor. If you do it the long way, you would have 2 factors of 4x minus 3. Okay. So question 3, I've got the A, B, C, and D done there. E, my hint was to common factor. So just follow along here. Common factor was the first type of factoring we did on Monday. So you look for whatever goes into all the terms. They're all even numbers. So 2 does. We divide every term by 2. And show that step. You have to show that step. Then you look and you decide. If you don't want to do this fast method, you don't have to, right? You can look for 2 numbers that multiply to 81 and add to negative 18. Negative 9 and negative 9, and set up your brackets. If you notice that half of negative 18 squared is 81, then you noticed that it's a perfect square trinomial, and it factors to a binomial squared where the root of x is x, the root of x squared is x, the root of 81 is 9, and it's a subtraction, whatever sign is in front of the middle term. So you can just go straight to that. But if you want to not do that, that's totally okay. And then the next one, notice how there's 2 that's common, there's a t that's common, and the first leading coefficient is negative. So we want to factor out a negative 2t. We always want the first term in the bracket to be positive. So if this is a negative, you've got to factor it out. Okay. Then it's actually a simple trinomial. If you notice, so really your first thing is just to look at the constant term. If it's a perfect square, then maybe it's a perfect square trinomial. If it's not a perfect square, then don't think about this fast method. Find the 2 factors. Okay. So half of negative 14 is negative 7, squared is positive 49. So it is a perfect square trinomial. So you can set up your bracket squared. The root of t squared is t. The root of 49 is 7. And whatever sign is in front of the t term. 7 all squared. Yep. It is, but it doesn't work for all of them, right? So it's just, you got to look at that last term. And so saying that, if you turn over to the next page, this is where we're going to find that value of k that makes it a perfect square trinomial. Okay, so what we were doing was we were taking half of the coefficient of the x term, and squaring it. And if that value was the product of these, then it was a perfect square trinomial. So now, do that. Well, 2 divided by 2 is 1. 1 squared is 1. So that's pretty straightforward. K has to be 1 if it's a perfect square trinomial. Doesn't ask you to factor them, so just state the value of k. I just did it. Take half of the coefficient of x and square it, and that's your value of k. It's back to that chart over here. This here. Okay, b over 2 squared has to equal the product AC. And that's what we were doing in all of those brackets when I was testing these out. So here, half of negative 10 squared is positive 25. Can't be negative 25 because negative 25 isn't a perfect square, right? Got to have a positive. Guys at the back, are you following along? Earbuds out. Okay, this one here, half of 6 squared is 9. Now notice that this isn't a simple trinomial. So this 9 has to be the product of 9 and k. Well, what must k be then? 1. Okay.
How is k 1 on the last?
Because it has to be the product of these two, the coefficient of the x squared and the constant term.
Times k. Oh,
Correct.
It has to be 1 to equal 9.
Yes, so this has to equal 9k, so k equals 1. Okay, now, last type of factoring. Really, this is the last type, difference of squares. When we do factoring on Monday, it's really all the same methods, except you might have more variables in it. So nothing new, but this is a little bit different because these are all for binomials. So we've just done 3 lessons on trinomials, 3 terms. Now we save the easiest for last. Difference of squares is binomials. Okay. So first question in this is expanding. So this is last week's work. Expand those binomials out and see what kind of expressions do you get. How many terms do you get? Do you get 2? Do you get 3? Or do you get 4? Okay, so do that now. So when we're expanding out these binomials, I showed the steps. You could do it in your head. When you're subtracting 5x and adding 5x, the terms go to 0. But I showed that in this step, and I ended up with x squared minus 25. Here, the middle terms added to 0 again, so I got a squared minus 49. This one, the middle terms added to 0 again, and I got 16x squared minus 9y squared. Take a look at each of these terms. This x squared is a perfect square. Just the 25, without the subtraction, is a perfect square. A squared is a perfect square. Just the 49, without the minus, is a perfect square. 16x squared is a perfect square. 9y squared without the minus is a perfect square. So we call these, whatever we get here, a difference of perfect squares. Difference means subtracting perfect squares, right? So those are what our result is. How did we get that? Because really all the other binomials that we were multiplying together, we always got either 4 terms that simplified to 3, or maybe some didn't simplify if we had more than one variable. But take a look at these binomials. You'll notice that the first term is exactly the same in all of them. The last term is the same if we don't look at the operation. So 5 and 5, 7 and 7, 3y and 3y. One is a plus in between, one is a minus. Plus in between, minus. Plus in between, minus in between. So we call those conjugates. So when we multiply 2 binomials together that are the same except for the sign, and I'm just going to put here, they're called conjugates, binomial conjugates, or just conjugates. That's what they are. 2 binomials that are the same except for the signs. When you multiply them together, you get a difference of perfect squares. And we just abbreviate that to difference of squares. So to go backwards, if you have a difference of squares and you're asked to factor, you set up your 2 brackets, you put the root of each term at the beginning of end of each bracket. One has a plus, one has a minus. Yes?
You read that out loud, I can't read it.
you get a difference of perfect squares. Okay, and really it's here. So you should also notice when this happens, the result is always. So here, yeah, this is a repeat. I don't know why we should have just put that right down here. Anyway, whatever. So simplified form of x plus y times x minus y will be x squared minus y squared. You don't need to show any work. And we talked a little bit about that when we were expanding, not too much, just a little bit. So then when we're factoring this, easy peasy, root of the first term, root of the second, one has a plus, one has a minus. Okay? Now, obviously, they're not always going to be just variables. They'll be numbers. Might not have two variables. So just always take a look. You have to sort of start inspecting each expression. Is it 3 terms? If it is, then you do the methods that we've been doing the last couple of days. If it's 2 terms, then you look, is it a perfect square? Yep. Is 64 without the sign a perfect square? Yep. And is it a difference? Yep. So now 2 brackets. Root of b squared is b, goes at the beginning. Root of 64 is 8. At the end, one has a plus, one has a minus. Doesn't matter which. That's why I said it's kind of the easiest one. It's pretty fast. Always look for a common factor. Next one, difference of, now this is 9x squared, but that's a perfect square. 9a squared. A squared is a perfect square. So this, 2 brackets, the root of 25 is 5. The root of 9a squared is 3a. One has a plus, one has a minus. Now that one wasn't in descending order of degree, but we'll just leave it like that for now. Next one, 2x squared. Is 2x squared a perfect square?
No.
No. So we cannot factor it right now. But take a look. Does 2 go into both of the terms? Yes. So common factor it out. And look in the brackets. It's a difference of perfect squares. Subtraction, x squared is a perfect square, 4 is a perfect square. So 2 brackets. X goes at the beginning, 2 goes at the end, 1 has a plus, 1 has a minus. Oh, sorry. Next one, 2 terms, squared and 9, so that's the difference of squares. Root of n squared is n. Root of 9 is 3. 1 is a plus, 1 is a minus. Doesn't matter, you can put the minus in the first one or the second one, but just one of each. Okay, looking at E, 36x squared is a perfect square, 4y squared is a perfect square. It's a difference, so you could factor it right now. We're going to notice something though if I do that right now. So don't copy what I do yet, but doing it that way, I would get 6x and 2y. One as a plus, one as a minus. Problem is, take a look in the brackets. So in each bracket, there's a common factor of 2. So I would then have to factor out a 2 from each bracket. That's a pain, and usually students forget. So that's why I said don't copy this down. I'm going to erase this, and common factor first, what we've been trying to drill into you, right? 4 goes into both. Then divide, what are you left with? 9x squared minus y squared. Now, that's still a difference of squares, but it's in completely factored form once you do it, right? Root of 9x squared is 3x. Root of y squared is y. One has a plus, one has a minus. Okay? Is that a difference of squares though? Yep. So that's this is the tricky one here. That is not a difference of squares, so you can't factor. Okay? So if you said it was b plus 8b minus 8, expand back. What do you get? You get b squared minus 8b plus 8b, which goes to 0, minus 64. And that's not what that is. So this can't be factored. Nope, try it. B plus 8. So b plus 8 times b plus 8 is going to be b squared plus 16b plus 64.
Oh, yeah, yeah.
Sorry, it's not, there it is, all the way down to there. Okay, so if it's a 2 terms and a plus in between, you cannot factor it. And that's the last one, right? Okay, so today we have about half an hour. You can start on the practice. We're not going to do we'll do the check-in very start of Monday's class, because I do want to show you your part A of your test.